All right, we are going to cover some questions from the practice of statistics, section 3.2. And there you go, section 3.2. We have several questions that people had in our homework. So we are going to be covering 37, 47, 49, 53, 57, 71, and 73. All right, our first problem is number 37, and it's kind of like an interpretation question. We expect a car's highway gas mileage to be related to its city gas mileage. Data for all 1,198 vehicles in the government's recent fuel economy guide give us this regression line. Predicted highway MPG equals 4.62 plus 1.109 times the city MPG. What's the slope of this line interpreted in context? All right, so I've given you guys some scripts for interpretations, and you probably should use them. You can definitely kind of stray from this a little bit, but you need to make sure it has all of these things in here. So I can see that the slope is this 1.109 because that is being multiplied by the explanatory variable, and the interpretation for this would be for each 1 mile per gallon increase in city mileage, the predicted highway mileage will increase by 1.109 mpg. Yeah, that's it. So it's always kind of for each additional, whatever the explanatory variable is, the predicted, whatever the response variable is, will increase by the slope. Part B, what's the y-intercept, and explain why the value is not statistically meaningful. So 4.62 is the y-intercept. And I should put a unit on this, mpg. So notice that this would mean that when the city mileage per mile per gallon is 0, the highway is 4.62. That does not make sense. So this would mean the highway mileage for a car that gets 0 mpg in the city is 4.62 mpg. That does not make sense. Basically, a car can't have 0 mpg in one place and have a miles per gallon in another place. Like, if it doesn't have an mpg, that means it's just not driving. So it doesn't make sense. Part C, find the predicted highway mileage that a car gets. All right, this is really important. I saw a lot of people had questions about this, this predicted. They were like, how do I find the prediction? This is crucial. So it comes from the least squared regression line. In this case, that was 4.62 plus 1.109 times the city MPG. So I need to plug in 16 and see what I get. So that ends up giving me 22.36. Okay, so this one gives us some data about new birds and returning birds. So you're trying to figure out, like, based on the number of returning birds that you have, how many new birds are you going to have? So use your calculator, make a scatter plot, use it to find a regression line, and then it has some things. So I'm going to go to this tablet. Here it is, and I typed in the numbers, and I went to 2 quantitative variables. That's what we'll do for all the scatter plot problems, and then I typed in the percent return and the new adults. I hit begin analysis. There it is. I would love to calculate the correlation in the least squared regression line. So notice it goes ahead and gives you the least squared regression line up here. And then here is the equation of the line. Okay, so I'm going to use that over here to talk about part C and D. All right, so the least squared regression line was, and I'm going to add a hat on that y in a second. Don't worry about it. It's 31.9 minus 0.304x. And remember, we should always say what these are. So where y is the predicted number of new adult birds, and x is the percent of birds returning. Okay, I need to add hats on these. So I need a little hat there, and I need a hat there. All right, so that's what B is. Part C says explain in words what the slope means. So the slope obviously is this negative 3.04. So let's talk about what that means. We just did an interpretation question, so you'll notice that this looks really similar. For each increase of 1 in the percent of returning birds, the predicted number of new adult birds will decrease by 0.304. Okay, so some important things I wanted to point out. Notice again, for each additional one of the explanatory variable, the predicted number of the response variable will, and you need to say increase or decrease. This was a decrease because it was negative, 0.304. I should say birds, I guess. That's the unit for the new adult birds. D, calculate and interpret the residual for the colony. So whenever you're calculating residuals, remember residuals are the actual value minus the predicted value. So I need to find what the predicted value is. And I just mentioned this in the last problem. I find predicted values by plugging it into the least squared regression line. So I'm going to do 31.9 minus 0.304. And then it was saying for 52%. So I would plug in the 52%. And that gives me 16.092. And then remember the residual is equal to actual minus predicted. So I'm going to do the actual one for 52% is right here. It was 11. See that up in the table? So I'm going to do 11 minus 16.092. And I get negative 5.092. Now, it did ask you to interpret, so don't just calculate and stop. You need to interpret it. So this, and I also kind of gave you guys a script for this, but I think it makes a lot of sense. In this colony, there were 5.092 fewer new adults than expected based on the percent of returning birds. So there were, it was this, that's one way to put it in context. Basically the prediction was 5.092 more than what happened actually. Question number 49 actually refers to the one that we just did. It says use your calculator to make a residual plot and describe what this graph tells you about the appropriateness of using a linear model. So I'm going to go back to my Statlet here. I had already, because I had calculated the least squares regression line, the Statlet automatically makes a residual plot for you. Notice there's not really a pattern here. It doesn't like curve. It's not like below, above, below, above, below, above. Like it's fairly mixed here, not a really big pattern. That means that a linear model is appropriate. So for part A, I'm going to say because there is no obvious pattern in the residual plots, line is an appropriate model for these data. Which point has the largest residual? Explain what this residual means in context. So I'm going to go back to the graph. Largest residual means positive or negative, like just which one was the farthest away. So notice the ones on top, the highest it gets to is like 5. And it has the residuals here, which is kind of nice. This one looks to be the farthest away from me, and look, it's at negative 5.8, so it's really close to 6. So that's the largest residual. And I would say something like the point with the largest residual, just kind of like reframe the question, is at 66% returning and has a residual of about negative 6. And then it asked you to explain what that means in context. So this means that the colony with 66% returning birds has about 6 fewer new birds than expected. Or than predicted. So it has 6 fewer than what the least squared regression line would have said. And you could say something like the least squared regression line predicted there would be 6 more than what actually happened, or you could say there actually were 6 fewer than what was predicted. And that would cover both. Okay, gonna keep moving along. 53, the Trans-Alaska Oil Pipeline is a tube that is formed from 1/2 inch thick steel and that carries oil across 800 miles of sensitive Arctic and subarctic terrain. Crazy. The pipe segments and the welds that join them were carefully examined before installation. How accurate are field measurements of the depth of small defects? The figure below compares the results of measurements on 100 defects made in the field with measurements of the same defects made in the laboratory. The line y equals x is drawn on the scatter plot. So we kind of have defects in the lab, defects in the field. Let's describe the overall pattern. Remember, pattern is really kind of like another word for form. So I would say there is a positive linear. It's not particularly curved. It's fairly linear. Association between the two variables. And notice that like the bigger you go, the more spread out these are. So I think that that's something to note about the deviations. So the bigger the lab measurements are, the further they deviate from the pattern. Part B, if they all agree, then the point should fall on the line y equals x drawn on the plot, except for small variations in the measurement. Is this the case? Explain. So clearly they don't all fall exactly on the line, especially as you get higher. So I would say even that they systematically fall below the line. So most of the points that deviate fall below the y equals x line, which means that the field measurements are too small compared to the lab measurements. So the lab measurements are getting bigger. These are getting bigger too, but they're like not getting bigger enough. They should be like up here. Part C, the line drawn on the scatter plot is y equals x, not the least squared regression line, because they were saying it's supposed to be y equals x. And so you're kind of comparing what it's supposed to be. How would the slope and the y-intercept of the least squared regression line compare? So personally, I would think that this line would tilt. Like I would imagine this line going down this way. And maybe the y-intercept going up a little bit. So I'm kind of envisioning a line that looks like that. That way it hits more of the points. It might not be quite that extreme. So how would the y-intercept, the slope and the y-intercept compare? On mine, it looks like, there we go, sorry. It looks like the slope decreased and the y-intercept increased. Yeah. Because notice that black line, like when it tilts like that, it gets less steep, but also the end of it goes up, which makes the y-intercept go up. Okay, for 57, we're back to talking about the bird colonies. So we have R squared and S. Explain what they mean in this setting. So y'all, again, interpretation is everything. S is the standard deviation of residuals. R is the coefficient of determination. So here's what I got. For R squared, I would say about 56% of the variation or variability, you could say either one. Variation maybe is better, but about 56% of the variation in the number of new adults is accounted for by the least squared regression line relating number of new adults to percent returning. Okay, so again, this should start looking really familiar, but basically, like, you fill in the blank with the variation or with the percentage. In the here, this is whatever your y context is accounted for by the least squared regression line relating whoops, that's the y context, sorry. Relating the y context to the x context. So you can basically like fill that in every time you want to do R squared. S is kind of similar. I mean, as far as like having a script, I would want to say something about okay, this isn't exactly it. Let me look at my script real quick. Your book had a slightly different script than what I have, but it is really similar. So the actual, in this case, the y context is the number of new adults. So the actual number of new adults is typically about 3.67 birds away from the number predicted by the least squared regression line. Okay, so again, I can kind of use this script. This is the y context, and then this is S. Last two, number 71 and 73 were multiple choice. So we're just choosing one answer. Which of the following is not a characteristic of the least squared regression line? The slope of the least squared regression line is always between -1 and 1. Right away, I'm like, bam. R is always between -1 and +1, but not the slope. The slope and R are not the same thing. Let's look at B, C, D, and E just to see how those are correct. So the least squared regression line always goes through X bar, Y bar. That is true. We talked about that recently, actually, when we were talking about outliers. The least squared regression line minimizes the sum of the squared residuals. Yes, you really should know that definition. That's what it does. The slope of the least squared regression line will always have the same sign as correlation. That's correct. So like if the slope is positive, then R is going to be positive. If the slope is negative, R is going to be negative. The least squared regression line is not resistant to outliers. Also correct. We talked about that when we added some points and we saw the line shift around and tilt. So A is the non-characteristic. So that's the correct answer. For 73, using data from the 2009 LPGA Tour, a regression analysis was performed using X equals average driving distance and Y equals scoring average. Using the output from the regression analysis below, determine the equation. Okay, this is super, super easy if you remember what these things are, like how to read this. So we did do one of these in class with the warm-up. So let's take a look, or if you didn't see it in class, like if it was one of the days that we had where we had an asynchronous day because my odd and even classes are off. You definitely should take a look at your book. You can always look at examples in your book. It explicitly went over this. Really, all I care about with the equation of the line is those two guys right there. And specifically, this one is always going to be the y-intercept, the one that's like next to constant, which makes sense to me because that's a constant. It's not multiplied by anything. And this one is going to be your slope. You do need to know how to read one of these mini tab outlets for the test. So make sure you know that's the y-intercept and that's the slope. And it looks like the one that matches that is C. There you go.